Question 1. Based on the information Mr. Patel is consulting on a commercial rooftop unit upgrade, the existing system often cycles on and off, causing uneven temperature distribution and higher energy costs. What should Mr. Patel recommend to improve system efficiency and comfort? A. Increasing the condenser fan speed to improve heat rejection. B. Installing a variable speed compressor to allow modulation of cooling capacity. C. Adding oversized ductwork to reduce airflow resistance. D. Using a higher C-rated thermostat for better temperature control. Answer. Correct answer, C. Explanation. Oversized ductwork reduces airflow resistance, allowing more consistent and efficient air delivery, which improves temperature distribution and reduces cycling. Increasing condenser fan speed can improve heat rejection but won't address short cycling caused by load mismatch. Variable speed compressor helps with capacity modulation but without proper airflow. Comfort issues remain. Higher C-rated thermostat does not. Thermostats control set points but don't directly improve efficiency or cycling behavior. Question 2. When faced with a residential split system showing high indoor humidity, Ramirez considers possible causes. Which of the following is the most likely cause she should investigate first? A. The evaporator coil is undersized for the load. B. The outdoor air intake is too small, limiting ventilation. C. The thermostat is set to heat mode during summer. D. The system is oversized and short cycles frequently. Answer. Correct answer, D. Explanation. Oversized systems short cycle frequently, reducing runtime and limiting moisture removal, leading to high indoor humidity. An undersized evaporator coil wouldn't handle the load but usually results in insufficient cooling rather than humidity. Small outdoor air intake affects ventilation but is less likely to cause humidity spikes. Thermostat set incorrectly is an operational error but not root cause of humidity and cooling needed. Question 3. From a practical standpoint, Mr. Thompson must select a refrigerant for a light commercial ERF system operating in a moderate climate. Which refrigerant should he prioritize considering safety, efficiency, and environmental impact? A. R400 TINA due to its high pressure and zero ozone depletion potential. B. R22 for its established performance and widespread availability. C. R134 for its low global warming potential and wide use in refrigeration. D. R32 for its high efficiency and low global warming potential compared to R400 TINA. Answer. Correct answer, D. Explanation. R32 offers better energy efficiency and significantly lower global warming potential than R400 TINA, making it a preferred choice for modern VRF systems. R400 TINA has zero ozone depletion but high debuan pressure. R22 is phased out due to ozone depletion. R134 is mainly used in refrigeration ERTVIC and has a higher debutant than R32. Question 4. In light of recent developments, Lee is designing a ventilation strategy for a commercial office to optimize indoor air quality and energy efficiency. Which approach best balances fresh air intake with energy conservation? A. Maximizing outdoor air ventilation at all times regardless of occupancy. B. Utilizing demand-controlled ventilation with co-sensors. C. Sealing the building completely and relying solely on air filtration. D. Using natural ventilation through operable windows exclusively. Answer. Correct answer, B. Explanation. Demand-controlled ventilation adjusts fresh air intake based on occupancy via co-levels, maintaining air quality while conserving energy. Maximizing outdoor air always wastes energy when occupancy is low. Sealing the building eliminates ventilation, risking poor IAC. Natural ventilation alone is unreliable and not controllable in commercial buildings. Question 5. Considering the evidence Mr. Nguyen is helping a customer choose between a heat pump and a gas furnace for heating in a moderate climate, which factor should he emphasize most in his sales approach? A. Heat pumps provide cooling but are less efficient in heating than gas furnaces. B. Gas furnaces generally have higher upfront costs but lower operating costs. C. Heat pumps offer year-round efficiency and can reduce carbon footprint. D. Gas furnaces are quieter and easier to maintain than heat pumps. Answer. Correct answer, C. Explanation. Heat pumps provide efficient heating and cooling year-round and reduce carbon footprint by relying on electricity rather than fossil fuels. Heat pumps can be more efficient than gas furnaces in moderate climates. Gas furnaces typically have lower upfront costs but higher carbon emissions. Noise and maintenance differences are less significant for decision-making than energy and environmental factors. Question 6. Through the lens of sales strategy, Mr. Roberts encounters a customer hesitant about upgrading to a high-efficiency system due to cost. Which approach best addresses this objection? A. Highlight the upfront rebate offers and tax credits available for high-efficiency units. B. Emphasize the luxury features and aesthetics of the new system. C. Focus on the increased complexity and maintenance of high-efficiency systems. D. Downplay the cost difference to push for a quick sale. Answer. Correct answer, A. Explanation. Highlighting rebates and tax incentives provides tangible financial benefits that offset upfront costs and help justify investment in efficiency. Luxury features might interest some but don't address cost objections directly. Increased complexity and maintenance concerns undermine trust. Downplaying costs can lead to buyer remorse and lost trust. Question 7. While examining a proposed load calculation for a mid-sized retail store, Chang notices the cooling load is significantly underestimated. What is the most probable cause? A. Incorrect assumptions about internal heat gains such as lighting and equipment. B. Overestimation of infiltration rates leading to excess cooling load. C. Use of manual J instead of a more detailed manual N calculation. D. Exclusion of solar heat gain from windows in the calculation. Answer. Correct answer, D. Explanation. Excluding solar heat gain from windows causes underestimation of cooling load because solar radiation can be a major heat source. Incorrect internal gains would more likely lead to overestimation. Overestimation of infiltration increases load, not underestimation. Manual J is standard for residential. The commercial buildings require manual N, but load errors are more likely from missing solar gain. Question 8. Given the circumstances, Mr. Allen is selling a ductless mini-split system to a customer concerned about indoor air quality (HVACR). Which feature should he emphasize most to address HVACR concerns? A. The system's inverter-driven compressor for energy efficiency. B. The multi-stage filtration system with HEPA and activated carbon filters. C. The compact design and ease of installation. D. The ability to cool multiple zones independently. Answer. Correct answer, B. Explanation. Advanced filtration with HEPA and activated carbon effectively removes particulates and odors, directly improving HVACR. Inverter compressors improve energy efficiency, but not HVACR. Compact design is a convenience feature, and multi-zone cooling offers comfort control but does not inherently improve air quality. Question 9. From the perspective of system performance evaluation, Garcia is reviewing data showing excessive static pressure in the ductwork of a newly installed system. What is the most appropriate corrective action? A. Increase the blower speed to overcome the static pressure. B. Inspect and reduce duct obstructions or improperly sized sections. C. Add more return air grills to balance the system. D. Replace the air filter with a higher MERV rating filter. Answer. Correct answer, D. Explanation. Installing a higher MERV filter increases static pressure, worsening the problem. The best approach is to inspect and fix duct obstructions or improper sizing to reduce static pressure. Increasing blower speed can damage the system and waste energy. Adding return grills might help airflow but won't directly address duct restrictions causing high static pressure. Question 10. For many years, Mr. Carter has promoted SEER ratings in his sales presentations. How should he now incorporate HRPF ratings when discussing heat pump systems to customers? A. Emphasize that SEER only measures cooling efficiency, where HRPS measures heating efficiency. B. Suggest that HSBF is less important because heating is usually supplemental. C. Avoid mentioning HSBF as it complicates the sales pitch. D. Focus solely on HSBF as it is the latest industry standard replacing SEER. Answer. Correct answer, A. Explanation. SEER measures cooling efficiency, where HRPF measures heating efficiency. Both are crucial for heat pump performance evaluation. Ignoring HSBF overlooks the heating aspect. Heating is often the primary function in cold months, so HSBF is highly relevant. Avoiding or focusing solely on one rating neglects comprehensive system understanding. Question 11. Given the circumstances, Mrs. Walker is assessing an old gas furnace system that frequently fails to ignite. What is the best initial recommendation she should give to improve reliability while maintaining cost efficiency? A. Replace the entire furnace with a high-efficiency model. B. Inspect and clean the pilot assembly or replace the ignition system if needed. C. Increase the gas pressure to improve ignition speed. D. Switch to an electric heating element to avoid combustion issues. Answer. Correct answer, B. Explanation. The most cost-effective first step is inspecting and cleaning the pilot assembly or ignition system, as dirt or malfunction often causes ignition failure. Replacing the whole furnace is costly and premature without diagnosis, increasing gas pressure risks unsafe operation and code violations. Electric heating may be less efficient and more costly to operate in this context, making it a less practical recommendation. Question 12. In a modern context of ventilation, Mr. Sanchez is designing a system for a laboratory with hazardous fumes. What ventilation strategy best ensures safety and compliance? A. Use a standard mechanical ventilation system with high air exchange rates. B. Implement local exhaust ventilation with dedicated fume hoods and make-up air systems. C. Rely solely on natural ventilation by opening windows during operation. D. Use positive pressure ventilation to keep fumes inside the lab. Answer. Correct answer, D. Explanation. Positive pressure ventilation would trap fumes inside, which is unsafe for hazardous labs. Local exhaust ventilation with fume hoods and proper make-up air is the industry standard to capture and remove hazardous contaminants at the source. Standard mechanical ventilation alone can dilute but not effectively remove hazardous fumes. Natural ventilation is unreliable and insufficient for hazardous environments. Question 13. Across different scenarios, Mr. Kim is tasked with recommending equipment to reduce the environmental impact of a refrigeration system. Which refrigerant choice aligns best with this goal? A. R134A due to its non-ozone depleting properties. B. R404A for its widespread use in commercial refrigeration. C. R1234A because of its very low global warming potential and compatibility with existing equipment. D. R22 as it is reliable and widely available. Answer. Correct answer, C. Explanation. R1234F is a next-generation refrigerant with very low global warming potential and minimal ozone depletion, making it the best choice for environmental goals. R134A is non-ozone depleting but has higher global warming potential. R404A has HIDWN and is being phased out. R22 damages the ozone layer and is no longer produced or used in new equipment. Question 14. Considering the evidence, Alvarez notices a customer's HVAC system frequently trips the circuit breaker. What is the most probable cause and what should she recommend? A. The compressor is overcharged. Recommend releasing some refrigerant. B. The air filter is clogged, causing the blower motor to overheat. C. The system is undersized, requiring frequent cycling. D. The electrical wiring is faulty or loose. Recommend qualified electrician to inspect. Answer. Correct answer, D. Explanation. Frequent breaker trips often indicate electrical issues such as faulty wiring or loose connections, requiring professional electrical inspection. Overcharging refrigerant causes high pressure but rarely breaker trips. Clogged filters cause airflow issues but more commonly lead to overheating, not breaker trips. Undersizing causes short cycling but not usually electrical breaker faults. Question 15. In response to customer feedback about noise complaints, Mr. O'Neill is evaluating an air handler. Which component modification most effectively reduces operational noise without sacrificing airflow? A. Installing variable speed blower motor. B. Adding sound absorbing foam around the ductwork. C. Increasing the size of the return air grill. D. Using higher MERV rated filter. Answer. Correct answer, A. Explanation. Variable speed blowers can reduce noise by running at lower speeds when full airflow isn't needed, balancing comfort and sound reduction. Sound foam can help but may restrict airflow if improperly installed. Larger return grills improve airflow but don't directly reduce noise from the air handler. Higher MERV filters increase static pressure, often increasing noise. Question 16. The core principles of load calculation require accurate data when calculating the heating load for a small office, which factor must be included to avoid undersizing the system. A. Only internal heat gains from equipment. B. Solar heat gain through windows and infiltration losses. C. Cooling load adjusted for occupancy. D. The SEER rating of existing equipment. Answer. Correct answer. C. Explanation. Cooling load and heating load differ, however, ignoring cooling load or occupancy can skew overall sizing. Solar heat gain and infiltration must be accounted for in cooling, but also influence heating by reducing the needed heating capacity. Relying only on internal gains risks undersizing. SEER rating doesn't influence load calculations directly. Question 17. With respect to sales communication, Mr. Johnson encounters a customer struggling to understand the benefits of a smart thermostat. How should he explain the value most effectively? A. By focusing on the thermostat's advanced technical specifications. B. By demonstrating how it can lower energy bills through programmable schedules and remote control. C. By emphasizing the sleek design and touchscreen interface. D. By explaining the wide frequency bands used for connectivity. Answer. Correct answer. B. Explanation. Customers relate best to clear benefits like energy savings and convenience. Programmable schedules and remote control directly impact utility costs and comfort. Technical specs and why details overwhelm and confuse. Design features appeal but don't justify purchase as strongly as energy savings do. Question 18. When considering airflow dynamics, is Patel notes uneven airflow in a large office space. Which system adjustment best corrects this issue? A. Increasing supply duct size across the entire system. B. Balancing dampers to regulate airflow distribution in each zone. C. Raising the fan speed to increase total airflow volume. D. Installing an additional return air vent in the problem zone. Answer. Correct answer. C. Explanation. Increasing fan speed can temporarily increase overall airflow but may exacerbate imbalance if dampers aren't adjusted properly. Balancing dampers regulate airflow to zones, correcting uneven distribution effectively. Increasing duct size is major retrofit and costly. Additional return vents help pressure but won't solve supply air imbalance. Question 19. From a practical standpoint, Mr. Singh is selling a heat pump system in a cold climate. The customer worries about performance during extreme cold. Which explanation best addresses this concern? A. Heat pumps are ineffective below freezing and should be avoided. B. Modern heat pumps include auxiliary electric heat strips for backup during extreme cold. C. Heat pumps can only be used for cooling in cold climates. D. Heat pumps work best with natural gas backup systems. Answer. Correct answer. D. Explanation. Modern cold climate heat pumps perform efficiently even below freezing, with electric backup common but natural gas backup preferred for cost and reliability in many areas. Saying they are ineffective or cooling only is inaccurate. Electric heat strips provide backup but are less economical than gas in many cases. Question 20. Taking into account energy efficiency ratings, Lopez is explaining SEER and A to a commercial customer. Which statement best differentiates these ratings? A. SEER measures seasonal efficiency over variable conditions. EAR measures efficiency at a single standard condition. B. SEER is used for heating systems only. EAR is used for cooling systems. C. SEER and EAR measure the same thing but use different units. D. EAR is a newer standard that has replaced SEER. Answer. Correct answer. A. Explanation. SEER represents seasonal energy efficiency averaging different loads and conditions. It measures efficiency at a fixed condition, usually 95 degrees outdoor temperature. SEER applies to cooling and heat pump systems, and neither is heating specific. They measure related but distinct metrics, and neither has replaced the other. Question 21. In the context of system upgrades, Jenkins is evaluating A customer's aging rooftop unit that has frequent compressor failures. What is the most effective upgrade recommendation to improve system reliability and energy efficiency? A. Replace the compressor with high-capacity single-speed unit. B. Install variable speed compressor with enhanced protective controls. C. Add an external condenser fan to assist heat rejection. D. Increase refrigerant charge to compensate for leaks. Answer. Correct answer. B. Explanation. Installing a variable speed compressor improves efficiency by matching capacity to load and reduces mechanical stress, thus enhancing reliability. A higher capacity single speed compressor may cycle more, increasing wear. Adding a condenser fan can help but doesn't address compressor failure causes. Increasing refrigerant charge without repairing leaks risks damage and inefficiency. Question 22. When analyzing indoor air quality complaints in a commercial building, Mr. Simmons suspects inadequate ventilation combined with high occupant density. Which corrective action best addresses this issue? A. Increase outdoor air intake volume and improve filtration. B. Decrease outdoor air intake to save energy costs. C. Install ultraviolet germicidal irradiation UV lamps without changing ventilation. D. Add dehumidifiers to reduce moisture without ventilation changes. Answer. Correct answer. D. Explanation. Adding dehumidifiers helps control moisture but does not solve ventilation inadequacies or occupant co-buildup. Increasing outdoor air infiltration directly improves air quality by diluting contaminants and removing particulates. Decreasing outdoor air worsens IAC. UV lamps treat microbes but don't replace proper ventilation. Question 23. From the perspective of customer needs analysis, Mr. Chen is presenting options to a client prioritizing energy savings over upfront cost. Which equipment feature should he highlight most to meet this preference? A. The lowest initial cost equipment available. B. Equipment with the highest SEER and HSEF ratings. C. Systems with simple on-off compressors. D. Equipment with manual thermostats for easy control. Answer. Correct answer. C. Explanation. Systems with simple on-off compressors are less energy efficient than variable speed units and thus less aligned with energy savings priorities. Highlighting highest CSF equipment matches energy saving goals despite higher cost. Focusing on lowest upfront cost ignores operational expenses. Manual thermostats offer less precise control, reducing energy efficiency. Question 24. Throughout the course of a sales consultation, Mrs. White discovers her client is concerned about potential refrigerant leaks and environmental regulations. What is the best sales approach to address these concerns? A. Assure the client that all refrigerants are safe and exempt from regulations. B. Recommend equipment using DODOP refrigerants and emphasize leak detection technology. C. Suggest delaying replacement until regulations change. D. Focus on equipment aesthetics and brand reputation instead. Answer. Correct answer. D. Explanation. Focusing on aesthetics and brand reputation ignores critical environmental concerns, undermining trust. Assuring refrigerants are exempt is incorrect and legally risky. Delaying replacement prolongs exposure to environmental risks. Recommending DODOP refrigerants and leak detection directly addresses client worries and complies with current regulations. Question 25. Given the circumstances, Mr. O'Connor is evaluating customer's air conditioning system that cycles too frequently, causing discomfort and wear. Which system sizing adjustment should he recommend? A. Increase the system's cooling capacity substantially. B. Decrease the system's cooling capacity slightly to prevent oversizing. C. Reduce the thermostat's temperature set point to minimize runtime. D. Install humidistat to control moisture levels instead of adjusting capacity. Answer. Correct answer. A. Explanation. Increasing capacity to meet or slightly exceed the load reduces short cycling by allowing the system to run longer per cycle. Decreasing capacity worsens cycling. Adjusting thermostat set point affects comfort but not the root cause. Humidistats control moisture but don't affect cycling related to improper sizing. Question 26. When examining heat transfer principles, is Rivera explains to a client that conduction, convection, and radiation all contribute differently. Which example best illustrates convection in an HVAC system? A. Heat passing through duct insulation material. B. Warm air rising and circulating through a room. C. Heat emitted from heated surfaces like radiators. D. Electrical resistance heating within a furnace element. Answer. Correct answer. B. Explanation. Convection is heat transfer through fluid motion. In HVAC, this is warm air rising and circulating. Conduction is heat transfer through solids like duct insulation. Radiation is heat transfer via electromagnetic waves from surfaces. Electrical resistance generates heat but is not heat transfer mode. Question 27. While evaluating pricing strategies, Patel wants to maximize profit margins without losing customers. Which approach aligns best with this goal? A. Setting prices significantly above competitors regardless of value. B. Offering tiered pricing options with clear benefits at each level. C. Using the lowest price possible to undercut competitors. D. Avoiding detailed proposals to speed up sales. Answer. Correct answer. C. Explanation. Offering the lowest price might increase volume but reduces profit margins and risks devaluing the service. Setting prices too high without clear value alienates customers. Tiered pricing lets customers select based on value, improving satisfaction and margins. Detailed proposals build trust and justify pricing. Question 20. For the purpose of system performance evaluation, is Lewis measures a unit's air and finds it lower than expected. Which factor is the most likely cause? A. Oversized system running too many hours. B. Dirty condenser coil reducing heat rejection. C. Use of high-efficiency refrigerant. D. Correct airflow across the evaporator coil. Answer. Correct answer. D. Explanation. Correct airflow would maintain or improve it, thus it's unlikely the cause of low air. Dirty condenser coils reduced heat rejection efficiency, directly lowering it. Oversizing affects cycling but not it directly. High efficiency refrigerants improve it, not reduce it. Question 29. When considering control systems, Davis wants to recommend a building automation system that optimizes HVAC operation for a large office. What feature is most critical to include? A. Manual override switches for each HVAC unit. B. Integration with occupancy sensors to adjust settings dynamically. C. Basic thermostat control without remote access. D. Fixed speed fan operation for simplicity. Answer. Correct answer. B. Explanation. Occupancy sensors enable dynamic adjustment of HVAC settings, improving comfort and energy savings. Manual overrides are useful but not primary optimization tools. Basic thermostats lack flexibility, and fixed speed fans don't optimize airflow or energy use effectively. Question 30. Considering the evidence, Garcia is asked to explain why some refrigerants are phased out under current regulations. What is the fundamental reason? A. They are expensive to produce compared to alternatives. B. They have high ozone depletion potential and or global warming potential. C. They are difficult to handle and require specialized tools. D. They are incompatible with modern compressors. Answer. Correct answer. A. Explanation. The fundamental reason refrigerants are phased out is their environmental harm, high ozone depletion or global warming potential. Prompting regulatory bans. Cost and handling challenges exist but are secondary. Compatibility issues vary but aren't the main regulatory cause.